Hello everyone. Sorry for the poor lighting. Sorry for the weather. Sorry for the pandemic that the world has given us. But karibuni sana for the third installation of the ACEK Future Leaders Mentorship Program, mentorship sessions. We are carrying out our mentorship sessions, on Zoom because we've been restricted to holding gatherings. But since technology has granted us this, why not do it? My name is Alora Kenneth. I'm a civil engineer at Procon Consulting Engineers Limited, and I am the ASEC Future Leaders Mentorship Coordinator. I hope everyone can hear that as I still admit other guys. Now, to the uni students, karibuni sana. Preparing this thing has not been an easy task. It's been tough, but finally we are here. I just want to give you a brief on what ASEC Future Leaders is. So ASEC Future Leaders is the youth wing, per se, of a bigger organization called Association of Consulting Engineers of Kenya. Those are our fathers and mothers, and they decided that to have a larger reach, they should have a future. We have a youth wing that is going to sort of tap into this young markets of engineers. So we are the bridge between the young engineers, young professionals in the industry, and ASEC, and to a further reach we are the reach to Fidich or GAM and Gamma. So today's session, when you look at your schedule, So when you look at the schedule, I'm supposed to be introducing the panelists. We have Engineer Kibara. I think I saw him logging in. Sorry, let me just admit one more person. So Engineer Kibara, karibu sana. Engineer Kibara is an engineer at Pinnacle Towers, an engineer, contract administration engineer at Konza Technopolis. Now you should take note of his craft because he's working on such an interesting project and he has such an interesting presentation for us. We also have Engineer Cedric Obonyo, who is a highways and transportation expert. Cedric has worked on Eldoret, Webuye Road. He's also worked on numerous projects with Kura, I think, and he has 10 years experience. He's just waiting to be confirmed as a professional engineer. So, karibu sana, Engineer Cedric. I think you've logged on. Then we have Irene Akot, who is a Egerton alumni and who will be a water and environmental specialist. So Irene is working for Prosperity, I think, yeah, and she'll tell us more about the craft she does. Then we have Mohammed Rashid is a assistant materials engineer at Abdul Malik, who has previously worked with, I think, APEC on the ICD, where the inland container. So I'm sure he has a lot of experience in terms of materials and is willing to share a bit of that with us. Then lastly, we have one of my good friends, alumni of Jkuat also, but cleared in 2009, a very highly proficient construction engineer, Engineer Lawrence. We will learn a lot about construction contract administration from him. I'm sure even I will learn a lot. So, having introduced all those people, I don't know whether Engineer Ukari is online. Engineer? Engineer, are you online?
He got himself in.
Say what?
Hello?
Yeah.
Can you guys hear me?
Could you just increase your volume a bit? I don't know, on your mic.
Oh, hello.
Hello, I can hear you, but your volume, there you go.
Oh, so good morning, everyone. It's afternoon. Hello.
Yes, we can hear you. Go on.
I'd like to take this chance to welcome you all to this mentorship session. My name is Hesbon Muriasi, and I'm the vice chair of YPF, the Future Leaders, ACEK Future Leaders. My comment is that it will be a general comment that we need to, as you graduate, you need to foster some love for the profession. And that whereas we complete school with the intention of, what we have in the back of our mind is that we should start earning and make money, having spent all this time learning engineering, it will be good to also think of it about in terms of what can you actually contribute to the profession, even as you are starting out. And that whereas in the first 2 years, there's an aspect of being trained further, getting to learn how it's done in the field, I would say that sooner or later, probably even exactly after the 2 years, it will be about what you can do. Whether you remain with the same employer or you go to another employer, they will be expecting that there's certain things you can do based on your experience thus far. So if you've been in roads, you must be able to take up one of the aspects of the road or in a road design project, or whether it's construction supervision, and contribute without him needing another person to closely monitor your work. So aim that in these first 2 years, you develop some competence, practical competence that can even help you. There's something out here we call PJs, which is like side projects that you do, which are not necessarily by your employer. It could be that you've been doing traffic counts, or you've been doing structural designs for buildings, for blocks of flats, and so you've developed some competence that you can comfortably on your own design an entire building, and ask somebody to check for you, and it doesn't find a lot of mistakes. So this is after 2 years, you should be able to do this comfortably without doubting your skills. And so this is one aspect, developing competence. The other one is, I've said, is the contribute to the profession. Join these associations, whether it is your yearmate WhatsApp group, whether it is a WhatsApp group that actually, or an association that combines the different fields, subfields, with architects, with other engineers from other fields. Be there. These associations will not come for you. And then there will be too many again. You'll have to choose which one you want to side with, because after some time, you'll find there's one for your year, there's another one for, Nairobi University of Nairobi students. Probably find one that you will actively participate in so that you are noticed. And other than that, I would actually wish you guys a good mentorship session. Those would be my comments for now.
Thank you so much, Engineer Okari. Fun fact, we were with Engineer Okari in high school. So our knowledge in engineering stems all the way back from 2005. So this is quite a wide knowledge base. So thank you so much, Engineer Okari, for your wise words. Now, as the moderator, I'll say we are 5 minutes behind. Now we have to move chap kabisa. So according to your schedule, the first engineer to present was Engineer Francis Mwangi. Are you there?
Yes, I'm on.
Please, kindly take us.
I don't know how you do presentations on this forum.
So you can either share the screen or I can share for you. Which one would you prefer? Engineer?
Let me know if that is visible to everyone.
There you go. I think yours is sharing. There you go.
Good afternoon, everyone.
Good afternoon.
My name is Engineer Francis Mwangi, a former classmate of Alu here, the moderator. I'm very happy to have been called to mentor one of ours, basically where we grew. So I hope that for 1 or 2 minutes of yours that I'll take, nitaweza kuwasaidia muweze kujua how to maneuver through the first 2 years of engineering, especially in civil works. So I would say grab that cup of coffee, flip through Reynolds. Reynolds is that book that every other time you'll need for you to be able to do your designs in structures. I hope the presentation is loading quickly. So in structural engineering, I'll say there are 3 bold categories that one would consider the building construction engineering. Basically, this is structural engineering for the buildings. You work with architects, quantity surveyors, and the basic built environment fraternity. There's road construction engineering, where you might be involved in box culverts construction.
I think there's been a technical error. Hello? There, he's back. Sorry about that, guys. Engineer, we've lost you a bit.
Hello?
Yes, we had lost you. We had lost you. I think you need to go back to the second slide and just rush fast.
Poor connectivity on my end. We were on the second slide where we say that there's a building construction engineering. This is a construction where you are working with where we are working with the built construction industry members. There is a road construction engineering where you might be involved in box culverts, such things, normal culverts, and of course there is bridge design. All these are elements of structural works that you might be involved in. On to the next slide. The areas that might be of interest or the ones that you might land yourselves in consultancy jobs, whichever you get, contracting jobs. In there, you'd see it's one of the projects that we are working on. That's a water reclamation facility project that we are doing at Konza Technopolis. And you'll note that in this slide here, it has all the disciplines that we are talking about. There is a consultant who is an Italian. There is a contractor also who is an Italian. There is an employer representative that will be explained in the contract administration bit. The employer representative is a Lebanese in this project. And of course, the employer is now Konza Technopolis Development Authority, or the government in this case. So the other area that you might find opportunities are academia and freelance. As somebody rightly mentioned that you might get chances to do your projects as PJs. Those are personal jobs. And you need to actively look for those because they will determine how well you are able to navigate in this engineering world. So how do you go about it? I would say look for that opportunity and then you play the hand that you are dealt. When I was leaving school, I knew I would be a civil engineer all through my life. But when I was looking for that opportunity, I was unfortunately not able to get a civil engineering post. So what I got was a structural engineering post, and I had to work through that to ensure that I am able I was agile enough to be able to take what I was dealt and come up with something. I hope this is still clear. It's telling me I'm unstable on my end. So the hardest experience to acquire is the first 3 months. So just if you get any opportunity, just pick on that opportunity. 3 months down the line, you could always decide on what you want to do with your life. I would say keep your campus notes very close. the TOS notes that you had, the traffic notes that you had, and in this case, especially the design notes that you have. Those are going to be critical as you start your first 2 years. Attend the mentorship programs. You've been told before in the keynote. Attend the mentorship programs, and then you choose the ones that you see are suiting your profession. I would say also know where to refer. People and books are your resources in your first 2 years. After that, you are supposed to be able to handle the projects on your own. I would also advise you to register as a graduate engineer at the earliest possible. Behind the screen, you'll see a picture of one of the projects that we are doing. That's a box culvert. It is called a utility tunnel at Konza Technopolis. And in this utility tunnel, it's a 2.5 by 2.5 box culvert below the road surfaces to be able to allow for all the utilities to be underground and to be repaired without interrupting services on the roads or such things. So what do you need going forward? I would say in design, you need to know how to design the elements. One element at a time, just like the note state. Start with the roof design, down to the slab, beams, columns, bases, then the other ancillary elements like ramps, stairs, and lifts. Most critical element is load takedown. The load paths should be very clear. Load path basically in this sense is how are the loads being transferred from the topmost level all the way to the foundation. It is also advisable to know how to use softwares in your design, both of course design and presentation of the same. But those are advisable to be used in subsequent years after you have a mastering of the manual design. So what is load takedown? This is the exercise of determining the loads that will be carried by the structure and carrying them down to the foundation. So basically you determine the loads that are being carried by the floors, and those are transferred to the beams. Beams takes them to the columns, columns to the foundations, and then of course the foundation now disperses the weight to the ground. Determine the design code to use for loads determination. The BS codes, Euro codes, or American codes can be a good start. There are very many other codes, and it all depends on where you are designing your works from. When the Kenyan standards are fully developed, then we are going to move to the Kenyan standards. They'll be the ones that will be the guiding codes for design purposes. After you're done with your design, then you should move to drafting. Basically, this is presenting the works that you've done. You should learn to draft on your first 3 months, whether you're working in a design office or for a contractor. It will be critical for registration. Please note that all these first 2 years that you are working on, you're trying to build a career for yourself. And in that building career, you will eventually require to register for you to have the benefits, the full benefits of engineering. I would say learn basics from personal initiative and then move to more complicated stuff by help of those with experience. This is what I did. I just took YouTube. I went through the AutoCAD basics of a draft.
I think he's gone silent again. Engineer, can you hear us?
Drawings are what will communicate your works to the external audience. Basically, your drawings should communicate your intentions to laymen without the need for further clarification. If you have sent your drawings to the site, you don't have to be on site to explain to the person who is laying the formwork, the person who is doing the steel. You don't need to be on site for them to understand your intentions. They should be able to pick on this, and you are only required to go there to do confirmation through the supervision, which would be the next thing. The aim of practice is registration, and of course, enjoying the full benefits of the profession. So after design and drafting, you need to follow up through the project by supervising. Be guided in the supervision process by either your employer or a mentor if you don't work in a design office. There will come a point where you find yourself, you have a side hustle that you've been working on, but you don't have you are maybe employed in academia, or you're employed in a contractor's site office. So you might need to get somebody else who would take you through the supervision bit. This one you need a mentor, because you wouldn't do supervision on your own, at least for the first 2 years. I would say pay special attention to reinforcement spacing, cover to reinforcement, formwork placement. Basically, this is the formwork for engineers is just to determine the size of elements. If the column is given as a 200 by 400, then of course the formwork will determine that. And for cover to reinforcement, ensure that you have spacers on the spacers, of course, holding the rebars back from the formwork. For reinforcement spacing, just follow the drawings and ensure that what has been drawn is what is being implemented on the ground. And critically, at reinforcement overlaps. So basically, when you have elements where reinforcement cannot run through, like you have a 13-meter span, and the rebars that we have in the industry are 12-meter spans, you might need to know where to break the break the rebars so that you have adequate overlaps. This is advisable to get the information from the design codes. If you're using BS standards, you would get that in BS 8110, for example. So, of course, you need to document your progress as you're going along the practice. The first 2 years, that's where you'll find most of your challenges, and you need to know how to document those challenges well enough, and of course, present them to the team that finally will be assessing your registration. So I'd say have a logbook for documenting tasks, and note everything that you are doing. Take special note of challenges in the industry and their possible solutions. I would also advise members to attend a professional interview preparation at the earliest possible for you to know how to prepare your registration process. Remember, it starts on day one. It's not after 5 years. If you get the chance, start at the earliest possible. I would also say take time to enjoy the small successes. If you've been able to be involved in a project that is finalized on, remember to pat yourself on the back and say that that was because of your achievements, because of your strength. The references that might be useful as you start your first 3 years would be the British Standard Codes in Kenya, and Euro codes, of course. We are in the process of adopting those. So for you to do the loads, take the loads calculations, you might refer this on BS 6399. Then there's BS 8110, that's for concrete design. BS 5950, that's for steel design. BS 8004, that's for foundation design. BS 5268 is for timber design. BS 5400 is for bridge design. I would advise the members to look for Eurocode equivalents of this to just have an understanding of what the industry is about. I'll first jump the question and answer and go to a few of the things that we are doing at Konza Technopolis. The first frame, if it's visible to you, we are in the process of laying a GCS on site. That's a graded crushed stones. On the second picture, that's the utility tunnel. It will host most of our utilities. That's a water pipe there, potable water pipe. On the other racks, we are going to have solid waste systems. We'll have, on one side, we'll have the wet utilities. On the other side, we'll have the dry utilities. We have bitumen spraying. That will be explained better by whoever is taking roads or materials. GCS again on another section. The middle frame down is a junction of the utility tunnel. And on the extreme right is the water reclamation facility, or a sewer plant, if you wish. So I would take question and answers, but if my minutes allow, I might want to present to the team a video of what we are doing at Konza Technopolis as I close it off.
Okay, I think you can go on with the video, but I would prefer we collate the Q&A for the Q&A session at the end. So if there's someone who can take down questions for the structural guys from the Jkuat students, I think that would be okay.
I hope the screen is visible. So this is the campsite for the contractor.
Not yet, engineer.
Okay. A minute. Is it visible now?
Yes, it is. Yes, it is.
Okay. So this is the contractor campsite for the main project that we are doing. It's a 40-kilometer street network with water and all the other subsurface utilities, basically the horizontal infrastructure for the project. It has both the offices and the accommodations for the contractor. And that is Konza Technopolis. Along, just before you get to Konza Technopolis, there's Mombasa Road. And then those are the roads that we are doing in the city. You'll note that the utility tunnel that I was talking about has been partially covered. There's some sections that are already done, and backfilling works are already ongoing in those. You have the subsurface utilities. This is a stormwater drain pipe being placed. And welding, of course, happens at the junctions for it to have a connectivity with the manholes. This section here is the water reclamation facility or a sewer treatment plant, if you wish. That's the progress. That's one of the mechanical offices. It was being cast. The progress is 2 months late on this video, so there are some things that you'd note in the pictures have progressed much further. These here are called electrical cabins. It's where the transformers, the electrical transformers will be placed for reticulation of power to the parcels or plots. That's part of the utility corridor. Runs across the whole city. As we said, we need the utilities below ground, and whenever we are doing repairs, we don't want to be cutting the roads or something of the sort. This is the section that will have our water treatment plant. The water treatment plant is envisioned to cater for the 200 to 300,000 population that will come in the city. That's the quarry crushing. That's the crushing plant at the quarry. This is off the city on the Kajiado side. In the background, you might see the SGR station, the Konza SGR station. This is the quarry site where we are borrowing our rocks from. And the rocks are gotten by blasting. Material is transported back to the site, of course, for laying on the different areas. So that will be it from me. Thank you.
Wow, what a presentation. We thought you were going to present on structural, but what we are seeing, you've given us a very holistic view of civil engineering. And I would like to thank you, Engineer Kibara. And to the students, at least you've seen that when you're coming out of university, that is work. You should be speaking to this engineer friend of mine about placements and internships and everything. So I will be sharing all the details. Don't worry about it. It's not that we are just here to present and completely disappear. I will be sharing all the communication details of all the presenters so that at least you can reach out to them if you have any pressing issues. We can have one-on-one or even group discussions so that the conversation continues. So thank you so much, engineer. Now, next we go to where the citizens usually fight with the engineers, which is the transportation and highway engineering and pavement engineering by Engineer Cedric. I don't know whether you've logged in, engineer.
Yeah, yes. Hi, Alu, how are you?
How is everything, engineer? Mambo?
I'm okay. I'm fine. Welcome, everybody. Yeah, now, I had prepared for this mentorship, but I see Engineer Francis has given me a lot of BS codes until I was worried. Was I supposed to come also with those things like that? But it's fine. Thank you for having me.
Okay.
So, yeah, so, as on my part, I do roads and highways construction. Been doing it for 10 years, actually 12 plus attachment if I'm to add, and had a few things just to give people encouragement, the students, on what they expect within the first 2 years if they are going to venture in highways. And I hope I'm going to sway most of you to do highways and roads. It's the most interesting part of engineering, in my opinion. Okay, fine. If I can share my screen, I think I do it where? I do it,
it's right.
How do I share? Here.
Yeah.
Yes, here. You can see there? I've shared my screen now. Yeah?
Yes, there we go.
You can see it, huh? Yes. Now, my talk is going to be about what you really expect in the first 2 years of engineering, especially in the highways and transportation aspect of engineering. So the first thing that you need to understand when you want to venture into highways and roads is, number one, you need to ask yourself very pertinent questions. And the first question usually is why do we do highways and roads? Why do we build roads and highways? There are three main reasons why we do roads and highways for human beings. Number one is for access. Access means we are doing roads for you to be able to access where you live or where you operate from. For example, if you are going to town, you need access to go to Luthuli, you need access to go to the hospital, you need access to go to school. So we do those roads for access in the town areas or built up environment. So the second reason why we do roads is for mobility. During December, as all of us go to Ushago as if Jesus was born in our villages for Christmas, we use the main highways, for example, from Nairobi to Kisumu, from Nairobi to Mombasa, from Nairobi to wherever that we go. We use those roads for mobility to be able to move over a long distance from point A to point B. So those roads or highways are designed or constructed differently from the ones for access. So there's the reason why we also build roads for mobility. The third reason why we build the roads and highways and pavements is for specialized purposes. The kind of road you will have inside an airport, the pavement of a runway, for example, is different than the road from here to Mudurwa, from Nairobi, say, to Nakuru. The pavement that you have on the port side of the port where ships are coming to offload their cargo is different than the road that you use ordinarily. So we do roads and highways because of those three major purposes. And when you become a highway engineer, you are going to most likely deal with all these three aspects of roads engineering. Now, in the first 2 years, you are going to interact with something called, or rather I put it to myself as the expected, unexpected interactions. You're going to have interactions that you would not even imagine in your life you're going to have. Yet the reality of the matter is they're expected. Number one, you're going to have a lot of interaction with very senior and experienced engineers in the industry in highways and roads. Some of them have practiced for many, many years, 20 years, 15 years, 30 years. And you are there fresh from college, you want to try your hand in highway engineering, you're going to interact with those individuals. Also experts from other sectors, like for example, experts from the claims sector, experts from environment, but these are individuals who have been there for a long time. Actually, in Kiswahili, they say, wamekula chumvi. They've been there for a long time. Also, you're going to interact with skilled workers that have been operating these equipments we see on the road for many years. Some of them, they tell you they're working in Malindi in 1978, and they're still working today, an operator. So you're going to have to interact with those kind of people. And also, you're going to interact with those non-skilled workers, people who have just been told, come now, here's your daily wage, start doing this. So as an engineer in the highways section, transportation, you're going to interact with all these people and on a daily basis. The second interaction you're going to have is varied stakeholders. For example, you will have interaction where you have to talk to hawkers. You have to talk to, we call them PAPs. PAPs are project affected persons. You're doing a road which passes through somewhere where structures have to be demolished. So it is going to be your responsibility to have this stakeholder engagement with these people. So you'll have to interact with these people on a very frequent basis so that you can resolve the matter amicably. For example, like this slide here we are seeing is this, I took this guy photograph. I was doing some road here in Nairobi in the side of Mathare. So these are people that you're going to have to talk to. You get to hear the experiences and talk to them that, you know what, your hotel cannot be here for eating chapati every day because the road must pass here. So you're also going to talk to environmental enforcement people that you never imagined you're going to meet. Somebody who will tell you, no, you cannot cut this tree. If this is a Mugumo tree, it must be cut after a ceremony is done. There's a project I did, a place called Muratina Road, where there was a Mugumo tree that was on the center of the corridor. And for me, coming from Nyanza Western, I didn't see a problem to just take it out and, why are we delaying? But I had to interact with people who had to make me believe that I need to bring old men, slaughter goats, I don't know, do this blood and all these things so that the tree can be taken out for the road to pass. So these are the interactions that you are going to expect, especially within the first 3 years. Then lastly, you're going to also have interaction with the local. Within the first 2 years, you will learn that Nairobi Water has water services that they don't know about in the city or whatever it is you're doing your work. So when you begin doing work is when you realize there's a sewer line, there is a water line. So you'll begin to interact with them and understand the process of a requisition to relocate these services, interact with Kenya Power, know who is in charge of what in Kenya Power, and things like that. You will also get to interact with the local government authority people who might want even to take political mileage on your work, because these are roads. Roads are very sensitive, crucial amenities in the society. So you'll have to learn to talk to MCAs because they want to come, they want to advise you on how you need to do your work. They want to, an MP wants to advise you on how you need to employ which number of people. Like, for example, I was doing a road in Westlands. The MP came and was trying to teach me why I don't need to do a box culvert of 2.5 or not 2.2. Those kind of interactions are there, and you have to be prepared to dealing with them because you never thought about them. Now, I'll talk about your working environment. The first 2 years, immediately you leave college, you're going to throw yourself into a working environment. The first thing that hit me when I left college is that there was a long hours of work that you have to put in highway and road construction. This is because of very numerous variables and fixed elements. Sorry, like for example, there's the weather elements, you know, you plan to do work and then like now, you know, we have July and September. So most road works, if they're doing earthworks, you have stalled somewhere. There's also specialized material that sometimes we use in road construction that are imported and now they delay in coming. So, and then the timelines of execution, some of the programs that you're given by the client to implement are very squeezed. So you have to put in a lot of hours of work for you to achieve them. Eh? So you need to be ready to enter office at 6 o'clock in the morning and leave office at 7. But for me, for example, when I left college, the first job I got when we were doing the Kisumu International Airport rehabilitation, I used to get in the work at 6 and leave at 9:30, 10 every single day. So that is the environment you need to be prepared. You prepare yourself, find yourself inside. The second item in the environment you'll find yourself in is you're going to encounter severe ignorance from the public in terms of road construction. Like for example, news reporters will come to site, they don't know the difference between an excavator and a grader. So they call everything a bulldozer, for example. The public do not know what you're doing because there's a lot of ignorance shouting roads construction. One time, the last project I did, I was in a taxi, just a short story. The taxi driver was giving me a story. Yeah, there are some guys who are doing some road industrial area. They don't know what they're doing, they're just wasting time, and he's talking about my project. And he's telling me, giving me his opinion. So, and then he's comparing it with, say, for Chinese, he saw somewhere else. And you see these Chinese that are doing this road in Kiambu, they are doing it very fast. So there's a lot of ignorance. People don't know the various factors affecting road construction. You have to learn to be patient. You have to explain what you're doing. Number three, you'll find yourself in an environment where there's a constant emerging technologies that are being used in the design and computation in roadworks. For example, the software that I learned to use in 2010 when I began is completely different from what I'm using now. Because now I have to do my work using 3D. 3D was not there in 2010, Civil 3D. So there's going to be that constant emerging technologies, even in the materials that we use, for example. So you need you'll find yourself in that kind of environment. Number four, you'll find yourself in a place where you lack normal social interactions. You know, a normal person who has done accountancy, for example, you'll have time on Friday, you go out, have drinks, meet ladies. You know, you're young, you're looking for a partner to get married or to marry and live a normal life, have family time over the weekend. But within the first 2 years of highway engineering, there's a challenge in that aspect because you will lack a normal social interaction framework for yourself because the kind of pressure that you are going to be in, because the first 2 years you are more or less like the donkey of whatever is going on. You have to put everything together and push it. So you are getting home late, most weekends are not yours, so you lack those kind of things. And lastly, which is something which I think maybe the societies are dealing with, your pay, the remuneration is going to be a bit diminished. You will not start doing roads engineering and earn a lot of money when you are within the first 2 years of leaving college. You have to be content because actually in all the cases of high roads engineering, when you leave college and so somebody's learning, then have so much to offer to bargain for. Now, there are some 4 factors that I came up with, which you need to keep in mind so much when you want to mitigate disappointment within the first 2 years of doing highway engineering. The first thing you need to keep in your mind is you must be open and adapt and learn from all kinds of colleagues. You must be open to learn from the grader operator, You must be open to learn from the surveyor whom you're going to meet on site. You must be open, not block yourself and say, I'm an engineer, there's nothing, for example, a surveyor can teach me. You must be open to learn. You will learn so much if you're open to that. That way, you'll mitigate your disappointment on whatever you're doing. Number two, you must be open to career progression, because in highways engineering, it is very, very crucial for you to have a plan of career progression, where, as Engineer Mwangi just said previously, you have to start logging your work, planning and telling yourself when you want to professionalize whatever it is that you're doing, and also to learn the new trends that are coming up in roads construction. Number three, you need to keep in mind that you must be very open to work far away from home for extended periods of time, because it is very unlikely that you will find yourself after college in the first 2 years, you're operating within your home area. You'll find a project in Kilifi and you come from Bondo, for example. Like me, I come from Kakamega. I found myself in a place called Sotik first time. You see, so you must be open to work far away from home for extended times. Therefore, as a highway engineer, and this is something that affects very many roads engineers, you must have a planning of family setup. It's so vital to mitigate your socioeconomic impact of the work you're doing to yourselves, so that you know your spouse and your children are going to be staying here, going to school here. You utakuwa zurura ukifanya kazi, if I say so. So that is something which I advocate for young people. You need to plan it early. Otherwise, you will end up going to so many places with your family. And lastly, which is very, very important, is there'll be a time to make money when you're doing highway engineering, but it is not within the first 2 years. Because within the first 2 years, you really need to be sincere, to be very decent and honesty, because integrity is non-negotiable in highways. Why? This is number one, you need to survive and grow, and your mentors will note your sincerity and your honesty. And number two, the decisions that are made on roads and highways engineering affect so many people, so many things, and are impactful in a very big way because they cost a lot of money, which is taxpayers' money. So you really, really must be honest so that you can build yourself and grow from there. Now, why would I, when you're doing engineering school, it is open for you to do structures, water, or highways. So I asked myself, why would you pursue highway engineering? Number one is the satisfaction that comes when you before and after. When you go to site or design a road where there was nothing, and then now after the final product, it's a very, very good feeling. Number two, the satisfaction of impacting society with the amenities and facilities that shall be used and exist for many years. Meaning, you are going to do work that is going to live beyond, that's going to exist beyond your existence, you yourself. Because these roads and highways, they're designed to last for more than 100 years. So you're going to create an impact to society that is going to last a long time. So it's a good thing, I think, to do something like you're not doing it for yourself, but for the society. Number three is that when you do highway engineering, you're going to expose yourself to a lot of diverse environments and cultures, and you're going to meet very many people. I remember when I left college, and I was taken in at, when you're doing the Kisumu airport, my RE was a Bua from South Africa, Mr. Patrick Keynes, I've not forgotten him. The surveyor was a guy from Netherlands. So the cultures and the people that we interact with when you're doing highway engineering is so diverse, because our roads projects has a lot of different people from all over the place. And then number four, why I'd encourage you to pursue highway engineering is that you're going to use very specialized equipment which many people have no idea even what it is to start with. So I think it's a good thing to be special in a way, so to use equipment which nobody knows about. And then lastly, you will make some good money in highway engineering. When you professionalize, the pay is good. You'll be entitled to executing massive projects. I mean, roads projects are usually very massive, And in the course of you applying your knowledge, the pay will be very, very good. Now, that is why I end my presentation on the environment just within the first 2 years. I didn't want to bombard you so much, but I hope you enjoyed. And if the moderator will allow me, I'll just show you a few photos of what I've been talking about. Can I, engineer, can I do that?
Yes,
No.
as long as
it's fine. Wait, is that? Sorry. Sorry. Just a minute. Oh my God. How do I? I'm trying to I'm trying to get it. I'm trying to get it. Just a minute.
You can do
yeah.
a bit later.
Yes, fine. Let me look for it.
Okay.
Let me look for it.
I promise I will allocate you some space.
Okay. It's fine. Thank you. Thank you for your time, and I appreciate it.
Thank you so much, Engineer Cedric Obonyo. Even I had been privileged to work under a highways project. Sorry, I'm the coordinator. I'm still admitting, guys. I was privileged to work under a highway project, and it was the Thika Road, Lot 2. And there's one point that you had mentioned about ignorance from the public, yeah? And I faced that as a very junior engineer in Thika Road. So in Thika Road, this is what used to happen. If you're not Chinese, I'm not listening to you, honestly. So we had to run to the Chinese. You translate what you want. The Chinese, they go, they tell these guys if it's to be evacuated or something, because they could only listen to the Chinese, not a simple Luya engineer like me. But as we grew, our name is out there, and at least people know stuff. So thank you very much, Engineer Obonyo. The Q&A sessions, I hope you'll be around for it. Thank you.
Yes, I'll be around.
Yeah. So next we have Irene. Irene, did you log in? I hope so. Irene is here to talk to us about water and environmental engineering. And in fact, as a person who's never really put my toe in it, even I will be here to learn a bit of water and environmental. So Irene, are you here?
Okay, I'm here. I was just trying to find some pipeline that I did with GIS. I wanted just some people to know another way of design with GIS. So as Sabifula, just give me a minute, then I will start after that.
No problem, no problem. And before Irene makes her presentation, there are two things I would like to say. First of all, Potters, I think I saw you logging in. Potters should be the class rep of Civil 5 Jkuat. Potters, if you've logged in and you can hear me, if there's anyone from your class who's having difficulty to log in, you can just reach out to me personally via text so that we see how we can admit them. Second thing, there has been a bit of complaints about my webcam. I am sorry. I had put, what Mark Zuckerberg told us to put so that you're not surveyed. So I had put it, and then I've just removed it. So there's a lot of smudge, but I don't think you want to see my face. You want to see the presentation. So don't worry about my face. My face is on the presentation poster. Just concentrate on the presentations.
What's wrong with this?
So Irene, are you ready?
Just give me 2 minutes, actually, Lily.
Cool photos, by the way, Irene. Cool photos.
the only thing, that's what I don't have much photos, but those two I really wanted people to see.
I'm talking about your background.
Oh, wachaneni nyinyi. So, I don't know why I can't open that.
Yeah, I have the photos now.
Let him just share the photos when I'm looking for mine.
Okay, no problem.
Yes, I need to start screen sharing, no? Hey, screen sharing is where? Screen sharing is here.
Right down there.
Yes. Screen sharing is here. Can't find it. Where is it?
Screen sharing is usually at the bottom of the screen.
Yes. Good. Now it's here. Yes, I've seen it. There. Can you see it now?
That is loading.
You can see it now, no?
There you go. You can see it.
Good. Now, for example, I wanted to share just the participants. This is an overpass bridge section between Likoni Road and Enterprise Road. If for those who are conversant with Nairobi. Initially, the design that we did was to have an underpass, that particular section, so that we have traffic separated. But we realized that there's a very huge trunk sewer line under there, and relocating it, Nairobi Water gave us a bill of 1 billion shillings. Can you imagine that? So we had to change it. We could not do it. So we tried to go above the sewer line. So to separate the traffic to go above, it's the same. So we were doing beams. One of these beams, you see these are beams, there were 30 beams across the deck, and each beam was actually 200 tons. It was a post-station beam, 200 tons per beam. But the beams were not cast on top of the structure. The beams were cast down. That is why I was telling people highway engineering is very interesting. The beams were cast down, and then we had to lift them to come on top of the bridge where we are. So this crane that you are seeing here is a crane that can lift up to almost 260 ton capacity crane. Crane, 260 tons capacity crane. Okay. So this beam here was about 194 tons per beam. So they were cast here. You can see my cursor. Can you see my cursor? So this was the casting yard here. So we cast here, then you bring it down on a dolly, this truck, the truck here, and then you lift it on the crane with, of course, people controlling with some ropes on the side, and place it here on these piers. So it was very interesting because now it's something that it's very hard to experience it somewhere else apart from in highway engineering. What else? Something else. Sorry. Yeah. So these are us now placing the beam. So you are placing 1, 2, 3, 10. There are 3 sections, so 10, 10, 10 to make 30. And then yes. So this is just like a short. You can see it's like a short video of the crane lifting up the beam to place it on top here. So the crane lifts it and places it here. I think for me, that's what I wanted to share, just to show the people that it's very interesting to do highway engineering. Really, really get to experience this kind of things. Thank you. I'm done.
Okay. Before I start, because this image will just disappear, I wanted people to see the one with profile. It has just disappeared, but I will send it to the host so that he can share with people over WhatsApp. Now, this is a proposed pipeline extension, which I did with the WSTF in Bondo. from Jaramogi Oginga Odinga University. So survey and design was done with QGIS, and you see the way it brings it so nicely. You can see where each structure is, wherever it is, and all. And now with the image I wanted to share, will also give you the profile plotting. When there's a tool in GIS called, in that QGIS called
Sorry.
profile tool. Yeah.
Actually sharing an image, or
Yeah, I want to share an image hapo.
you want to share?
Yeah, but I've gotten one, so I'll just start and then I'll share another one.
Okay.
I'll just share another one to you so that you can give the students afterwards. So for now, let me share my presentation screen so that, first of all, I want to share this one and this one, this one. Yeah. Can everyone see it?
Yes.
Yeah. Now I can start.
Yeah.
I am called Irene. There's lightning in Nairobi mvua, lakini hiyo background msijali. So I'm a water and environmental engineer by profession from Egerton University. I've practiced for 3.5 years. I think I'm the youngest in this presentation and I'm excited about it. So from Egerton, you only do water and environmental engineering from first year to 5th year, and it is very, very exciting. So my presentation is
There seems to be some sort of noise. I don't know whether everyone can hear it. I don't know whether it is from your machine or what, or your interference. I'm not sure.
No. There is no, it's not mine because I don't have any person next. So for me, I want to share my first 2 years of experience, and I want to go very fast in this other one so that I can do water engineering and what it tells. So for the people who want to pursue this water and environmental engineering, it is very exciting. And it is the only branch of civil engineering where you can spend so much time with your family and not move much. So what I would say to the people here, when you get out of school, relieve high expectations. Those expectations that you have, and start thinking, oh, I'm going to have 200K, I'm going to have just relieve them. So, and immediately you get out of school, before you graduate, do something. So you can learn plumbing, you can do masonry, you can do CAD, but for water engineering, it is very crucial that you do GIS and EIA. GIS is Geographical Information Science, because 3 years ago, the Ministry of Water gave a directive that all water amenities to be mapped with GIS. So it is a new government directive, and it is good that you do GIS. I did mine for 3 months at KEWI. And then there is the environmental impact assessment that will come very handy for you. And also nanofiltration technology will also help you, especially when you're working with communities and you have to treat for them water urgently in small units. Then another one is to be patient. Just as the other engineer said, the pay is bad. Like you may find a place you're being paid 17,000, or you are being paid. You find a place you're being paid 17,000, 15,000. So you just be patient. And also you find that maybe the person who is supervising is giving you a lot of work, so you work more than every other person, like you enter earlier than people and you leave late than every other person. Be patient and persistent, and keep applying. Keep applying for jobs. Don't, you see, like me, when I came out of university, I once applied for an MD position for Ololeisa Water when they needed 25 years of experience, and I was called for the interview and I was second. So So people, you just apply anything anywhere. Then another one is creativity, innovation, and timeliness. So here, I wanted to say, your problem solving skills works better when you're creative. You know, when you get out and you're trying to harmonize your books and field work, it is only creativity that makes you choose the best practice and what to apply at what time. So there's some things that may not be just evoked direct, but you may need to bend it a little bit or do it in another way. Like, for example, when I was in an internship at Egerton University, again with the Egerton University, Egerton Water, we were given a small space to construct a water treatment facility on a quarter an acre, and we needed to treat 4 million liters per day. So what we did with the engineer in charge, I told him, why don't we just turn the plan the other way around? So the normal flocculation ponds, the way you know them, if you go there, you'll see they look. Unfortunately, I didn't carry the photos. So we swapped the plan for the side view and the side view of the plan. So the flock ponds look like massive, huge tanks that could carry 10,000 liters. So it means the water moved the other way around, and the flock ponds were now bigger, huge, and not in a conventional way, the way people see them and the way we are taught in class. And everybody was happy, and we achieve our aim. Then engineers tend to miss this one. This number 2, good interpersonal skills. You need to be somebody who interacts so well with casual workers, with the people that surround you, with the cleaners, with everyone, so that it makes your work environment very easy and enjoyable. Then, as always, I always say, there's a solution for every problem in these 3 ways: a new approach to the problem, existing approach that people use normally, and an improvised approach, and you'll find a way to go through. And then another one is love your work. Oh, these are iwe ujaluo person, love your work. And everything in water and environmental engineering is passion driven. You can imagine dealing with those sewage and
you're in and out. I don't know whether you can.
You don't know whether? I can't hear. Okay, so now, this is now what I want to give. I hope you guys are seeing. Are you guys seeing my screen and hearing me? Hello? So I want to start with water treatment. Now, in water and environmental engineering, it is one of the widest scopes of civil engineering, that even these that I've listed here are just some of them, but not all of them. So as a water and environmental engineering, you'll find yourself working with the in a water treatment facility and water companies. And the first thing that will be your jurisdiction is to manage the intakes. You find that different water companies have different intakes. Some have subsurface intakes and other groundwater. Subsurface like lakes, water reservoirs. Some do theirs with gravity, convey to the treatment facility via gravity. Others do by pumped. So, and it will also be your jurisdiction to manage and maintain the treatment plant, which will consist of flocculation ponds, sedimentation ponds, decantation ponds, filtration units, chlorination units, the storage tanks, and distributions. So the key in this area is you will always have to monitor the flow rates in a very nice, 4 times a day. And establish the demand. Like if you're serving Nairobi and there are 4 million people here. So you have to establish the demand of the people against the water that you are producing, so that if you are producing water that does not satisfy the demand at a go, or maybe when the demand is at peak, when everybody's at home, for example, in the morning hours and in the evening hours, then you'll have to resort to rationing that water so that everybody gets satisfied. Then in the initial stages, like you see the guy who was designing for that concept, for when you're doing a treatment facility, you have to project a population up to a long period of time, like 50 years, because population keep on growing, and the treatment facility is supposed to take them all that time. And another thing that will also be crucial in that area will be the retention time in each point: flocculation, sedimentation, decantation. The retention time is what will determine that you have the quality of water that is needed to be distributed to people by NEMA. Then after every 2 weeks, you'll need to be doing backwashing of the ponds, so that algae does not grow inside, and other organisms that will make people sick. And the second one is non-revenue water management. Now, in water sector, you'll find yourself as a non-revenue engineer, and your main work will always be, first of all, weighing the water. First of all, keep on, please. Are you not listening? And when you keep on saying Irene, you make me, I don't know, so what I was saying, non-revenue water is the percentage of water produced minus the water you sell to the people over the water you produce. So it is the key indicator of efficiency when you're dealing with water, when you're supplying water to people. And it's also the key indicator of good financial performance. So what normally brings non-revenue water is leakages, bursts. Some people do illegal connections, some stuck meters, and then other people have flat rates. So you'll find that you cannot account for that water when it leaves the treatment facility to the people. So how to deal with this and how I dealt with it when I was an NRW engineer at Sibo Water and company in Siaya, you have to map all the utilities, all the pipelines, all the sewer lines, all the manholes, everything, all the consumers, door to door, tap by tap, with GIS, and have a geodatabase of all those things, so that you can always know who you are supplying to, the amount you're supplying to, and when a leakage and burst occurs, when you have a functional geodatabase, it makes the management very easy. So that you can always know it is that area and the shortest route to go to, so that you don't lose water for a long time. Then also you have to do field audits every month. Okay, and lastly in that area is formation of district metered areas, we call DMAs. So, and you map all of them and their consumers. Yeah, and now the third one is GIS. Now, this one may be new to water engineers, or maybe they will have done it only as a unit, but this is a framework of gathering and managing data, so that it integrates well with the systems that you have for easier management. And it's a short course. It takes only 3 months at KEWI. I don't know, the other people who also offer it. And there are different softwares that is used. Me, I use QGIS because it's easy and it's free. Then there are ACEK-FL, DivaGIS. Those other ones are very expensive. They may take you over 100,000 to purchase. So this GIS will help you to map all the pipeline, all the sewer lines, all the utilities, all their pertinences, and you'll create an effective geodatabase that will help you have efficient maintenance and also for future development and expansion. So like when other branches of engineers want to do their development, maybe like a road or something, they'll just come and say, give us your geodatabase. And what will happen is that you'll just produce that database and they'll know everywhere what is where so that they don't get shocked. They excavate a place and all of a sudden sewage imemwagika everywhere. Then also it helps also in designing of profiles, especially when you want to do a new pipeline. There's a tool in that QGIS, and that app is called profile tool. You just key in elevations and you also key in their coordinate, and it just gives you the image from the satellite, and it draws the pipeline where it's supposed to pass, and also it plots the profile very nice and without so much fuss. And also you won't need even surveyors, wengi. You may just need one more person and your GPS, and also gives you good ways and routes for even repair works, pipe bursts, and satellite links, so that you can always even do survey and link other works that people have done on that area and in that place. And number 4, we have wastewater. So in water and now this is environmental engineering, and this is the area that I love so much with all my heart. So 80% of water that you will supply to people will come back to you as a problem, as a water and environmental engineering, so that you give it to them, they bring back 80% so that you deal with it as sewage, so that you treat it and dispose it in a most friendly way, so that does not harm the environment. And also we'll also have runoff, leachate, domestic water, agricultural runoffs, industrial waste. And all these will have different chemical compositions, biological compositions, and even solids presence. So here, as a water engineer, we will always be tasked, especially when you are designing also this, you'll be needed to take initial data from these people, these domestic consumers, industrial, especially on the effluent. Effluent is that influent, yeah. So that you know the quality of water that they discharge will determine the size and the design that you'll take to treat their waste, and also the sewer systems. So like the BOD, the COD, BOD is the biological oxygen demand, then the COD, chemical oxygen demand, pH. Those are the things that you'll need to do. So you have different water supplies providers have different approaches, but the one that I used to work for used to have biological treatment by ponds, biological ponds. So this one is to have a physical treatment at the entrance of the ponds, of the primary ponds, which is anaerobic pond, which will use to deal with screening and removal of solid waste before it reaches that anaerobic pond. And also it used also to pass through a grit chamber that will also remove sand. And then there was also removal of floatable liquids like oil, so that it proceeds to the anaerobic ponds. So in these ponds, people have different ways of, this one actually, this anaerobic ponds, there's no oxygen. So So the treatment happens without injection of oxygen. Then it will be followed by, okay. Hello?
Okay, I can hear you. I can hear you. I'm sure you
Okay.
have a lot to say.
Actually, I'm almost finishing water too.
But
Water and solid waste management.
okay.
You know,
One
actually,
moment.
water engineering is more, let me say, more wide than all those other branches. I don't know, you could have just given me a few minutes. I'm just finishing actually.
You can just give them the overview, and then I will share all the other relevant material.
Okay, let me just do another one. The last two, it will take me like 2 minutes. Then there is solid waste management. The solid waste management. So this solid waste management is actually dealing with separation of this waste into hazardous, recyclables, and biodegradables. Others I'll just send to you, the people, so that they see. And the key thing is also analysis of this data for this water, non-revenue, sewage, solid waste, so that you can always have control checks on what you are doing. And last but not least, I wanted to share this. I wanted to share this one. I wanted to share a photo. Yeah, this one. Let me see. Let me get back to. Let me just share this photo so that I close. I'm just sharing this photo so that I close. Let me see.
So it's
Yes, you see
sharing.
that one?
Okay.
You see that one?
Yes.
You can see that photo?
Yes.
Yeah, now that was a new pipeline that was done using the GIS. So the beauty of this one, the beauty of this tool and this software is that you can actually see things as they are on the ground. So you ushtuki yani, yeah. So na mwisho as I am now nikimalizia sasa, the last one, actually I won't talk much, is this one. I want to say to the people, get registered. When ukitoka, immediately get registered with the professional bodies and work closely with senior engineers for guidance and learning opportunities. Then I wanted to ask most of us, as we do career progression in water and environmental engineering, please, it's good that we take an interest in solid waste engineering in a deeper look, because you can see it is being overlooked, and you see the way solid waste is really treating us in an abnormal way. Yeah, thank you.
Thank you very much. It's been a pleasure. Today is the first time I've heard your voice. Very good presentation. And in case of any the technicalities, we'll share all these presentations. We'll share all this the recordings in case you want clarity. Yeah. So thank you very much.
My images I'll send to you so that you share to them, because I couldn't get them in time. Yeah.
No problem. We'll figure out a way around that.
Okay.
Haya, next. I hope hamjachoka. We continue. Sorry, we are a bit short of time. I hear the next presenter ni wale wa kuongea haraka. Isiolo, Isili, Mohammed, where are you? I hope you will rush very fast through this presentation, and you have to tell us first of all which project you're doing. Take it from there, Mohammed.
Thank you, Laura. I hope you can hear me. Can you hear me?
I can hear you.
And everybody else, thank you. Welcome all. My name is Mohammed Rashid. Irene said the water is wide, but I think she needs to experience materials. Material is very wide. My name is Mohammed Rashid. I graduated not long ago, 2016, from University of Nairobi with BSc Civil Engineering. Currently, I'm working with a consulting firm by the name AMA Consulting Engineers on a road project in western part of Turkana near South Sudan border. The project is part of a government of Kenya plan to connect Port of Mombasa to Juba through Kenya, South Sudan border. So first I will give an overview of the material, what material engineers do. I will go full technical like Irene did. Then I will briefly give some tips to those who are aspiring to go this route. So let me share my screen. Sorry. So I hope everyone can see.
Yes, we can see. We can see. This have to be a bit louder, probably.
Go a bit loud.
Yes.
Am I too loud? Okay, let me continue. I hope you can hear me. Material engineers, by the way, play a big role in all civil engineering projects. And for the purpose of this presentation, I will be biased towards roads. So what is the role of material engineers? Material stroke, we normally refer to material engineers in roads as also pavement engineers. So material engineers, by the way, design and maintain flexible pavement and rigid pavement using knowledge of soil and material properties. When we say soil, actually soil is one of the major components of material engineering, soil mechanics. So if you have interest in soil mechanics at the university level, I think you have a good start. So the other material that we normally have interest in as material engineers is a bit of knowledge on geology, rocks, and also bitumen. So before we continue, I mentioned about flexible and rigid pavement. Let me give an overview of what flexible and rigid pavement means. Flexible, the main difference between flexible and rigid pavement is the mode of load transfer. The flexible pavement transfer load through what we call particle contact, thereby distributing load from top to the bottom. In rigid pavement, where the main load bearing cause is the concrete slab that transfers the load to the subgrade level. The other difference is the binder in flexible pavement is bitumen. The binder on rigid pavement is cement. The other difference is the last one. Let me give the last one. Is in flexible pavement we can open immediately to traffic as soon as it's finished. In rigid pavement we have.
Are you able to share your presentation? Should I share it, please?
Is it not there? You cannot see it?
We can only see your quick access. Let me call quick access, your folder, but we can't see the presentation.
Sorry.
Or should I?
Yeah, I think you can share from your end.
I share it for you, huh?
Yeah.
Let me just locate it and leave. You can continue. You can continue with the presentation.
Okay. So those are the main difference. I mean, on flexible pavement, we can open it to traffic almost immediately. But for rigid pavement, since it is concrete requires time to cure. It takes 28 days to gain maximum strength. So we may not we may have to wait for 28 days. There are many differences, but because of time, let me just move on. Road engineering or road construction involves two main stages. Number one is a design stage, and number two, construction stage. In both of these stages, material engineers play a big role. Material engineers do play a big role, and were you able to share the screen?
Yes, I'm just trying to share it.
Okay, material engineers play a big role in both of these stages. I will start with the design stage. In design stage, these are some of the things that material engineers do. They involve, number one, they involve in survey of possible routes, okay? The first thing that's normally done during design stage of any road is surveying of possible route where the road is going to pass. Usually the main custodian of this activity is a highway engineer or the geometry engineer, but the material engineer has to be involved. Why? Because the foundation of the road is key to his activity. So when we say the foundation of the road, we are trying to avoid something called problem soil. Problem soil are expansive soil or soils that have low bearing capacity. When we say expansive soil involves soils that are susceptible to moisture fluctuations. When we and also cracking. Cracking, of course, as we all know, reduces the durability of pavement, thereby making road less durable. The next thing that is involved, that material engineers involved in, is assess traffic class or traffic data. Traffic engineers all collect. Remember, we design road in order to resist or to be able to carry loading from the traffic. Okay, so traffic engineers collect all their data. Traffic engineers collect all their data and analyze, and they give their findings to the material engineer or the pavement engineer, because it's one of the key design components. Just like buildings, we start also with buildings. We start with loading. The loading in pavement structure is the traffic. Okay. So moving on, the next thing in the design stage is the measure of the subgrade strength. I think you can move now to that slide.
Which one? Kindly.
Move on. Continue. Hapo. Hapana, rudi nyuma kidogo. Rudi nyuma kidogo. The previous slide. Yeah, measure of the subgrade strength. When we say subgrade strength, this involves determining the strength of soil on which the road is to be built. Okay, this is carried out by physical description of the outcrop, test of what we call pit excavations. This will help us assess the vertical change in soil profile, and also visually you are supposed to delineate or subdivide your alignment into soil, how the soil changes. Remember, you are dealing with nature. Nature is not uniform. So you need to subdivide the alignment according to how the soil is changing. So you are supposed to do also what we call test pits in order to assess the vertical change in the soil profile. You are supposed to also take samples from those soil pits and do laboratory analysis. You are also supposed to do, during this activity, do in situ bearing capacity using a device called DCP, okay? So based on all this activity, we assign subgrade class. This will also form a major component in the design of the pavement structure. So the next slide, as we move to the next slide, yeah, the next slide shows how the test pit looks like, and also how a dynamic cone penetrometer test. This will help you to measure the subgrade in situ bearing capacity. It will give you in situ bearing capacity. So as we move along to the next slide, the next activity is the choice of, remember we are supposed to build our embankment or the pavement structure above the ground. In this we use naturally occurring materials or gravels. So we are supposed to, as a material engineer, it's your responsibility to source for those materials. Also, we need to remember that availability of the suitable construction material within the project's vicinity plays a vital role. So it is the responsibility of the material engineer to source for those construction materials. So he's also supposed to assess the quality and the quantity of the material. What you need to know is during road construction, contractors are not paid for haulage. So it is that's why the government or the client hire a material engineer to ensure that we have suitable material within the vicinity of the road alignment. So as we source for this material, kindly move to the next slide. As we source for this material, these are some of the consideration these are some of the things we consider. Number one, standard of the pavement or the standard of the project road. Number two, overburden thickness. You need to, before you start exploiting for certain material, you need to check the overburden. Is it economically viable? Does it make sense? Number three, ease of exploitation. Do we have obstacles, things like mountains or rivers? Do we need to build culverts or temporary drift that could turn out to be very expensive for the project? So it's the responsibility of this material engineer to ensure that his point of selection is accessible. Also, he needs to check the material is in sufficient quantity. Remember, when the construction starts, the contractor will have to do, it's an investment, it's a big investment. He has to set up machinery, set up his crusher. So you need to ensure that it's sufficient in quantity. He also need to check he or she also need to check the quality of the material that he's recommending. Quality, mostly you are also required to have some knowledge of geology, how rocks behave or the nature of the rocks. Some rocks are acidic in nature. That's what you also need to know. You need to, rocks which are acidic in nature, one of the signs that they are acidic in nature is they have pores. What shows you that they have pores? They absorb water, high water absorption capacity. When you mix your asphalt using rocks that have high water absorption capacity, the likelihood of that rock having low bitumen affinity is very high. So when you use rocks that have low bitumen affinity in your asphalt mix, the road is going to undergo what we call premature aging because there's no bonding between bitumen and aggregate. When you have premature aging, the road looks very old within a very short period and starts deteriorating. And if the road starts deteriorating immediately and it was designed to last for 15 to 20 years, as a material engineer, you are going to be in trouble. So you need to ensure that the quality is good. So the last thing, as we move to the next slide in the design stage is, kindly move to the next slide, is the selection of the pavement structure. Remember, you have collected all your data, the traffic data is there, the subgrade material, the foundation soil, you have assessed it. You have assessed the source of embankment material. So you need to come up, after comparing all the international standards plus our local standards, you need to come up with a economically viable pavement structure. Okay, so with that, we need to consider the likely level and timing of maintenance, number one. Number two, probable behavior of the pavement structure. For example, in hot areas, you need to think very carefully about using asphalt concrete. Instead, what the client also recommends is we use what we call dense bitumen macadam or DBM together with the surface dressing. So those are some of the things you consider. The other thing we consider is, of course, the economic part, the cost. The economy is, as an engineer, you should be very economical because we are dealing with limited resources, especially as a developing country. So I will move to the second stage, which is construction. The next slide. Construction stage, this is all where all the fun is, depending with your motivation, how motivated you are. During construction stage, material engineers play a very vital role. They are the key person in road projects. Material engineers are the people, is the person who is being blamed when anything goes wrong, especially when the pavement starts failing. So you need to be very careful. The first thing as a material engineer you need to do is to verify design assumptions along the alignment. Why do you do that? Because most of the time, the engineer who did the design is not the same engineer who is present during construction. So regardless of what the design report says, you're supposed to verify those design report assumptions in the design report. The other thing you need to, because you all remember also during construction, you have all the resources at your disposal. You have all the machines. You have a fully set up laboratory most of the time. So you need to take advantage of that one and make sure that you approve everything according to the specification. The next thing that we need to ensure is, as a material engineer during construction, is in addition to these sources of material that have been indicated in the design report, you also need to source for more borrow areas. Of course, considering quality and quantity. You are also required to review method statement of the contractor as an engineer. Method statement means how the contractor plans to carry out his work. Of course, in the method statement, as a material engineer, you need to ensure that the contractor is planning to carry out, being conscious of the quality of the works. The other thing is you are also required to submit your quality assurance plan on how to, you plan to carry out your quality, you plan to assess the quality of during construction. You are also required to do mixed design of concrete and asphalt. You are also required to control quality of all the pavement layers. I think you are familiar with all the tests that are done during construction. So that is it. Those are that is the role that material engineers play in road construction. So kindly, let's move to the next slide. So what's required of you as a graduate material engineer? Number one, as soon as if you want to pursue this, you need to work in a laboratory with the technicians. You need to learn how to do the test, okay? One of the key role of a material engineer is how to operate a civil engineering laboratory. That is one of the key components of a material engineer. So you also need to know how to do the test yourself. Remember, in construction, there's a lot of cheating, okay? So technicians, most of the time, do cheat. So you need to learn how to do the test yourself as a material engineer. A good material engineer knows how to do all the tests, the required tests by him or herself. You also need to have what we call problem-solving mindset. Especially during construction, there are a lot of challenges and different problems. And the person who is called upon to solve problems is a material engineer. You should not be rigid as a material engineer. You need to first of all, go to site and you are required to go to site and solve problems. So as a graduate engineer, you should be present. You should try as much as you can to be on site, not in a design office, or material engineers are required to be on site to solve day-to-day problems. Remember, in material engineering, there's no software involved. There's no sophisticated software that you can sit somewhere in Nairobi or in some office and you solve problems from there. No, you are required to be on site. So make sure you grab any opportunity that will have you to be on site. The next thing that you are required to do is ready to work in some very remote areas or even hostile areas, especially during design. Yeah, so most of the time, the projects that require material engineers are out of town, very remote areas. So I think for you to be a good materials engineer, you need to grab any opportunity of these projects that are out of towns. That's, I think, how you will be able to learn a lot. Next slide. Okay, so what are some of the pros and cons of being a material engineer? Well, let's start with the pros. It involves nature. Remember, you're dealing with nature, and one of the things with nature is it's not uniform. So every day you are encountering a unique problem. So that one somehow is adventure, somehow, involving geology, soil mechanics, okay? The other thing is it involves exploiting new areas, especially during design. During design, you are required to walk. The vehicle is just following you, carrying your equipment or something. You're supposed to walk and assess the material by yourself. Remember, I said there's no software involved. So you're supposed to be physically on site, sometimes walking very long distance. Okay, so what are the cons? It's I didn't say that in water you can spend most of the time with your family. You can solve problems from your bedroom. This one you will be required to be away from your home and family almost all the time. Those are some of the disadvantages, and also any wrong decisions. Any wrong decision that you make. Material engineering is all about making decisions, and you have to make sure that you make all your decisions are right. Otherwise, it's going to cost the project a lot of money. The first person, whenever anything goes wrong in a project, the first person to be blamed or fired even is material engineer. So you have to be alert all the time. So those are some of the issues. So as we move to the next slide. Next slide. Yeah, so if you have good interest in especially road construction or material engineering involving roads, those are some of the references you can look. It has very detailed about materials. Number one is Kenya Road Design Manual, Part 3. The other one is Overseas Road Note 31. The other one is Ethiopian. You should also check other manuals from other countries, neighboring countries, like Tanzania has a very good manual. Also, Ethiopian Roads Authority Pavement Design Manual, Volume 1, has a very good analysis, detailed analysis, textbook-like analysis of what material is all about. The other one is ACEK-FL, 1993, also has a very good information on materials. Yeah, I think, I hope you have benefited from my presentation. Thank you for the chance.
Or I closed it too early. You had one more page.
No, I think that's it. That is it.
That's it. Thank you. Thank you very much, Mohammed. Mohammed has been one of my mentorship soldiers. Do you remember the first mentorship, one of the first mentorships we did in Sunshine?
Yes.
Thank you very much. Thank you very much, Mohammed. Tuendelee hivyo.
Welcome.
Yeah, thank you. Now, I know we are time bad. But I promise you, this last presentation, as I was reading it, I even just started smiling. And I hope the presenter is here to present about construction engineering. We have Engineer Lawrence. Engineer Lawrence, are you here? Njue?
I hope everyone can hear me.
Yes, we can hear you, Lawrence. How are you?
I'm fine.
Mm-hmm.
Now, let me just share my screen. Things have, it has taken quite a while.
If you're not able to share it, I can do it.
Try from this end. Tell me when it's successfully up.
The screen is successfully up. Woo!
Okay. Now I think I can begin. My name is Lawrence Mutuginjoy. I was an alumni of, or I am an alumni of Jomo Kenyatta. Glad to participate on this forum, especially for an institution I have been part of. Actually, I still do visit there a lot. I come to use the soccer field for some exercise once in a while. So for those who are still students and probably play some soccer, we can meet 1 or 2 times on the field. But matters today, my presentation is going to be just 5 minutes. I appreciate most of the presenters today have taken us through what I'll call is more technical engineering. We've learned actually what engineering practice in terms of design, and in the conventional way, what do you call an engineer? I'm sure whatever you've heard for most of them is what, when you went to school or when your parents convinced you to do civil, is what people envisioned. And when you meet on the streets after you graduate, you'll find the title engineer very common. That when you get into any social function or setup, they'll refer you to an engineer. They will mean the first 4 presenters. They will not mean me. Now, the reason why I say that is that I want to discuss from a point of construction engineering. Not very well looked up in the country, not very well developed in our country, and majorly because engineering has been, most of us, or most of the experience we've learned about engineering has come from the point of design and supervision, but not actually construction. I personally appreciated construction engineering with Thika Road when I could quickly see how Chinese had a very different understanding of implementing things. Yes, you are the designer, you want the roads done, you want the pavement done. Yes, you are a water engineer design, you want a dam done. You are a building or structural engineer, you want the structure done, you have a 60-story building. How do you achieve it? And these, I think, are the challenges that I feel we have not developed well in construction engineering. The reason I call it how to make money is because I'm encouraging most of you, or those who can, to consider construction engineering because it converts into a contractor. There's a big, normally a conversation in the industry that most of the works done locally are not to standard. And one of the reasons is that construction has been left to local guys who are quacks. Very few engineers want to participate in the construction part of the industry. Most of them practice as design engineers and supervision engineers. In terms of practice, I've also practiced enough in the side of design. Currently, I'm a resident engineer at Tatu City. It's very close to where the school is. And I think 1 or 2 of you will have maybe in their 2nd, 3rd, or 4th year attachment being with us. I'm not very sure, but I suspect because I've been with you or 2 of you during the attachment period. Now into the thick of the matter, my presentations are not ideally not very graphic and not very technical. I'm actually looking at it from what does construction engineering really involve? And I'm not actually going to present them. I'm going to talk to you about construction engineering. That just know in this market that we have, there are very few local, even design engineers who are professionals, who can actually be able to go to a site and direct the actual construction to happen. Majorly, this has come to be because of they have practiced longer in the office, and when doing supervision, they have practiced at what I call high-level engineering, where you give instructions, where you write letters, where you interpret design and such things. Things I've also done, but very few of them, even when they tell you they need an F1, F3 type of homework finish, they need concrete to be placed not in certain heights because of segregation. They need, like there was a very good demonstration about, I think a project in industrial area where they were lifting about 200-ton weight of a beam using a crane. Very few, even of the practice professional engineers, can actually tell you what is the name of the machine, where is it sourced, where do we have them, and how it can be done. And that's why we find that Chinese are get a lot of accolades or international contractors, because most of them are very well versed with the construction part of engineering. And it entails just a list of what I've put there. You know, to understand personnel management, equipment management, planning, scheduling and control, laws and regulations, formulation and appraisal, and project management. In terms of personnel and management, you have to understand people. Irene well discussed in saying you need to have good interpersonal skills so that you interact with the casuals. What I normally say is that in construction personnel management, when you're a construction engineer, you have to understand what it requires to do that. When I was doing, I've done a master's at Jkuat on construction engineering. My lecturer used to tell us, you need to understand the anthropometrics of the site. If you're telling somebody to lay a curb, and you know that his position is going to either squat or bend, how long can a human being bend and be productive? So that will allow you to know that I have a human being who can only be able to deliver 100 or 120 meters long of curb laying. I have somebody who can actually lay paving blocks for a square meters of this. It gives you the production ability. And if you want the same human being to produce more, then what kind of other support and facilitation should you do? This is very key in construction, because when construction is about money, that's what I'm saying, how to make money. If you don't estimate correctly how much output a laborer, a mason, a carpenter, a steel fixer can produce in a day, you're going to estimate the rate you're going to charge for his labor input wrongly. And that's why your rates are going to be poor or very high, you don't win your bid, or too low that you go at a loss. So it's the personal management part is first understanding the scope. Be on site, know what laborers do, interact with them, how do you motivate them and how do you produce. In terms of organization and management and development, is the same thing HRs do. If you have somebody who come in as a casual and is very good with his hands and is very productive and very disciplined, how can you coach him and train him to become a mason or to become something else? That where he earns an extra buck and also gives you more production. In terms of welfare management, these people, personnel is people. You need to understand to form welfares. Welfares in vitu kama chama. Welfares are things about circles and such things that relate to improving their life. You discuss about compensation. There are quite a number of laws that are related to this. There are very many what called common bargaining agreements that teach you on this, and also about their safety and health. PPEs on site, reflectors, helmets, safety boots, gloves when they are necessary. These are all things that you need to understand. These are not things that I'm telling you as a design engineer you will interact. You will recommend in the design book, but very few design engineers can tell you the cost of a glove, of a helmet, of a reflector jacket. But when you're a contractor, he will require your personnel to have it. So when you go to buy them and you don't really internalize what these things mean, and then you have to go and spend money you had not factored in your contract or in your quotation, then you start going to losses. The next item that is quite key is equipment and plant. Now, in terms of equipment and plant, I think Irene mentioned about casual, but I also thought either the first presenter or the second mentioned about operators who have worked for so long. When I talk about equipment and you discuss with some of those people that have been there for a while, you'll actually know what is the difference between our 120G grader and our 140H grader. What is the consumption of that grader in a day? If it consumes 80 liters of diesel, what is the production ability that is going to achieve for you? If I'm assigning a section of road or a dam or an earthwork processing, when I have one grader, how many water bowsers should I supposed to have? What is the capacity of the water bowser? How many maybe pneumatic rollers am I supposed to have? What is the tonnage? What is their vibratory capacity and such things? This will allow you to coincide one or two items so that when you're producing on site, you make money. Because if you have a grader that is underperforming, for example, in a real site scenario, especially in roads and earthworks, we normally assign a grader 2 rollers because a grader can produce up to 200, 300, 400 meters. But now if you have as a foreman or somebody who's leading the section who does not achieve that production, then your machine costing is being lost. And mind you, when you're doing your rating, you normally cost the equipment. There is also something called the depreciating effect of the cost. The longer the idle equipment stay on site, the longer you lose it. And the poor you produce, the more you're not performing in your contract. So when you come in as an engineer, the high hat, are discouraged to hiyo kimbelembele ya kujua uko juu, ulisoma miaka 5 na kila kitu. That's why we are not constructing, we are only designing. Calm yourself down, go to the field, learn, appreciate. Know when do you use a pneumatic roller, when do you use a ship foot roller, when do you use a flat roller, when do you use a 3-ton, a 10-ton, a 1-ton, all of those things. Then you start becoming relevant. Another thing that you need to is the depreciation analysis. You need to actually know what is the cost of acquiring equipment from the manufacturer if it's abroad, the bill of landing, the cost of shipping, the clearance cost, all the taxes involved, and loading it all the way to your yard. Alternatively, buying it from the local market, buying a second-hand machine. What are the advantages? It's business here. Engineering to Limaliza are the first 4 guys. The other thing is right machine for the right work. You can have, for example, an excavator that excavates and stockpiles, then a shovel that's come and loads to the tippers. But a shovel or a wheel loader. For you to decide, do I have just an excavator directly excavating and loading, or stockpiling for shovels to come and do? You actually have to understand which machine is right for which area. Again, it is not in the classroom. It is right on the field, see how they perform, go take the manufacturer's manual, compare what they recommend as part of the design, and see that you're achieving that. The next one is, because I didn't want to talk a lot, I skipped something, no? The next one is on construction planning and scheduling. This is the make or break it part about construction. When a contractor, umeenda site, umeshinda tender, umeambiwa fanya kazi, engineer amekupatia instruction, kwa mkali. Now, when that comes into bill, you are supposed to give a program of works that the engineer approves. Mind you, they look at you on the other side like you're not an engineer. Because wanajua kuna contractor na engineer. My encouragement is that when you're discussing contractors on the other side, they have actually engineers who are professionals, trained 5 years. Mesoma Jkuat na wakapitia kabubu. Mambo ikakuwa ngumu. Now, in planning, there's a number of softwares. There's MS Projects, Primavera. These are all softwares. Excel also, it's a bit outdated. But again, Excel is also a very powerful tool in planning, especially in simple projects. Something less than 50 million or 500,000 USD. Excel will work perfectly. Now, these softwares allow you to actually indicate your sequence of activities, the order in sequence, the critical path analysis, your resourcing, your put in precedences and lead times and lag times. You need to know when you're doing your program. For example, a project from January to December. April and May are normally wet months. October and November are actually wet months. If you put your earthwork activities around those periods, then your performance is going to be hampered. All these things, you actually have to factor them in your schedule. Schedules correlate directly with costs. Because if, for example, you schedule activities during the wet seasons and they are dry activities, dry weather demanding activities, then you are going to affect your cost and cash flow. In most scenarios in this country, I've not seen guys being very sensitive about cash flow. Contractor atafanya raise certificate venye anapenda. But actually, if you go in real markets where people are discussing money, you'll actually discover that even your cash flow projections, if you mess them up, then the developer doesn't pay you, because you told him that you'll need 80 million at the end of every month. For example, it's a 1 billion project, spread it after 12 months, you get about 80 something M per month. So if you tell me this is your production, or for example, it's not a linear curve, it has some few short months in the month where you have 60 or 40, then somewhere in the mid where all activities are spanned, you have big certificates. If May, you told me you're raising at 240, you raise a 120, and I had reserved in my bank 240 for you. You are not claiming, I will charge you interest. So construction planning, scheduling, and costing is a big thing. I'm encouraging, don't simplify construction. Don't think it is easy. I tend sometimes to think it's more difficult than design, with all respect to the design process, because I've done it for a while. And majorly because if you look at it, you'll never find in construction not understanding the design. But you have very many aspects of design where you'll be told, they'll be saying for specialist input. The specialist input is strictly a construction engineering aspect. The next slide is on construction law and regulations. When you are a contractor, you'll definitely be under contract for you to do work. A contract in Sharia. So lazima uelewe Sharia. There are very many forms of contracts commonly used around. In this country, the two common are JBC and FIDIC. The other bespoke contracts that are used, customized for specific projects. In very many scenarios, people play around with contracts. I had an example just yesterday. Somebody actually calling me, telling me that they did work worth 3.4 million. They're being paid 2.8. They're being paid 2 million and the contract sum was 2.8 million. And it's a very young contractor who's beginning up and calling me to perform a miracle. And when you ask them, where did the 2.8 million come from? They say, we went to site, we made a BQ, we quoted for the job. So I told him the client did not even give you a BQ. He did not estimate the quantities. All the mistake was yours. And since you're being treated 2 million because you have not finished the work, I told her the best thing that you can do is finish the work and claim 2.8 million. But you'll never get even the 3.4 million you're claiming without finishing the works, because you estimated works wrongly. So don't underpin what is your responsibility. Leave the quirks. Let's start getting the quirks out and coming in as professional engineers to come for the money the quirks are getting. The other part is tender. You need to know how to tender. You know the rules that you're using to tender. If an organization requires pre-qualification, how to prepare the documents for that, bidding, how they evaluate award technically and financially, and some of the rules. If you're going for the big tenders or you're working for the big contractors, you'll be required actually to know MDB, Multi-Title Development Mark Procedures and Guidelines for Procurement, and also the PPOA, the Kenyan Procurement Oversight Authority, and the Disposal Act that guides about our procurement in this country. These are legal terms, learn them. You need to know about taxes, things like the legal requirements, things like insurances. Most guys will ask you for bid bonds, will ask you for performance bonds, for work insurance benefit, for your staff, third-party assurance, contractor audits, insurances. All these are things that cost money, and very few in this Kenyan system of tendering are you provided to quote. So when you're developing your rate, you have to know how you're developing your rate to cater even for this cost. There are things like tax laws. You need to know, are you areas where you're supposed to pay VATs, income tax, and such things. There's environmental compliance. Unaenda kufanya kazi kwa site, ule engineer mulisoma na hapo classmate, kwanza ule alikuwa chini, wadaru wasomi, ndo sasa ako pande ya ari. He comes and finds you that you're actually doing bitumen plant, inatoa moshi. Anakuambia the machine cannot work here because it is not following the Environmental Regulatory Act rules or the NEMA report that was given, the EIA Act that was given. Sasa where you have already mobilized equipment on site, you start looking at him as an enemy. Reason being, he has a privilege because the Kenyan system of design and practice, and too many engineers, has a lot of privilege, the design and the supervising engineers. People who sit pretty somewhere and expect things to happen. So as the contracting guy, the construction guy, you actually need to be up and above those guys. That's what you can do in business. Otherwise, the contracts can frustrate you until everybody wishes to be an ARI, which will not be. The other thing is labor regulations. We discussed this on your skin about the welfare of the staff. You need to understand what you need to pay. NSSF, NHIF, which kind of deductions do you do? Paying their pay, which kind of insurances do you have, especially for sites? Other things of management, do you do bonuses and such other things? And the labor laws that guides the performance. These are legal requirements or laws that need to be very well appraised. The other one is project formulation and appraisal. This is where every engineer, I think, in this country is, okay, no, I'm not interacting with all of them. So for the sake of not throwing them in one basket. I can tell you for free that very many guys will not tell you what is the interest rate of return for their projects. They'll not tell you what is the NPV, what is the benefit cost ratio, what is the IRR. As in Aoni, like the Rashid will tell you, anataka lami yake ikuwe 014 asphalt concrete type 2. Mali unatoa mawe, yataki kujua. Asphalt concrete type 2 versus asphalt concrete type 1, how long distant it takes to actually the life and pavement of that road. These are things that very many engineers are not managing to do. Actually, I heard the other day that probably it's going to be, when you guys are going for registration as professional engineers, there's a demand now that actually you do it the textbook way, where you actually give, if you are doing a project, you have to show 3 other alternative solutions you gave as an engineer for you to choose your solution. Because now you only go and take one project, you're not asked how did you qualify it. So the formulation and appraisal of a project does not come here, the money element of a project. But let me look at it from a contractor point of view. You go to a project na Rashid amekwambia nataka uweke lami using 014, and then you find that the crusher machine that you can afford or you have in your yard haina conveyor belt ya kuallow the grading falls under 014. It has what can fall under 020. You need to be in a position to actually do an engineering technical report and give an alternative design for him to appreciate that your design can work, so that you save yourself the cost of setting up a new and fresh conveyor system or crushing and conveyor system for the aggregate, and him to appreciate that you are not compromising his standard. That is project formulation and appraisal. It deals about costing for you as an engineer in the contractor side. You need to look at if his proposal for use as of the material is gravel, and you are finding that you can actually put GCS as a sub-base layer instead of cement improved gravel. If that is his design, then I better have 2 layers of GCS where I can access rock cheaply and have a conveyor, have the machines to do that, than go and fetch gravel that is going to have my trucks run for 40 kilometers in badly maintained roads for me to meet the specifications. This all discusses project appraisal. When we read about private sector participation and project financing, contractor ni pesa bana. You go to the bank, you have letters, lines of credit, you're borrowing money. Actually, when you're starting as young contractors, like some of us who are still very young contractors, we borrow money a lot from our friends. Because umepatiwa kakazi is a small amount, maybe 20 million, you can't raise the amount, maybe it's 10 million, you borrow. So you have to make sure the money you borrow, you can afford to pay. You can afford to pay the small consideration or interest you committed to the people who are financing you, and you can still make money. But looking at it at a global perspective, project financing is a significant item. You will find that most guys in this country, what they have done, they have actually put up, especially the big contractors, they have bought property which they have taken to the bank as lines of credit. Lines of credit which allow them to access cash flow. And because if you don't have cash flow on a site, you can't progress. And I'm telling you, there are contractors you can go who have cash flows of 2 billion. Let me explain what that means. Jamaa anaingianga Equity executive branch, anakaa chini, anasema ataka kunywa chai ya chocolate, ana complain haina sukari. Before the tea girl aende sukari, na alikuwa amesign check ya 1.2 billion, because he has an already qualified and certified credit line of 2 billion. He has a 1.2 billion in his account. So that guy can actually do and facilitate and deliver any project he wants. But if you actually do not think about project financing, you'll be thinking, let me get the project and look for money. When you get the project timeline starts running. When you go looking for money, you start discovering people require securities and facilities. So let's look at those things when you discuss project financing. The other thing is like what you're doing, what Kenha is doing with the highway. You can actually have some of the systems where the private sector come and invest in a project as a contractor now. The contractor on Uhuru Highway, what he did, he came to, when Kenha proposed, he came and said, me as a contractor, I can actually come, do your infrastructure, and be able to recover my investment, and I'll not charge you anything. Then later, after I recover my money, I can go. That is what's going to happen with the elevated road, or is it the Uhuru Highway upgrade. Now, these are built, operate, and transfer, or built, own, operate, and transfer kind of arrangements that are there. If you're not a good contractor, come as an engineer, you will not actually be able to do this thing. The guy who conceptualized and did the numbers to come and tell Kenha, I need 25 years to recover this. Si mtu anacheza. So don't think that engineering only falls in the consulting firms, only falls working for the government, only falls working for the design element in this provision. It's also a lot that comes with the contracting side. Other areas are simply maybe advanced construction techniques. I can tell you for free, the guy who brought DECRA in this country has not done any engineering. The DECRA tiles we're using has not done any engineering. Those guys have made money, and even other people have come and made money on those things. And there are no engineers in that industry. Light gauge roofing trusses that are also very common. These guys are coming up business people. And we have engineers who actually can know what is the gauge of an aluminium, what is the capacity of an aluminium sheet profile, is it this thickness okay, what is the stiffness member. Mnafunzwa hadi to 6, mnaacha vitabu shule, mnaachia wanabiashara. And then when you come here, there's somebody who said engineers are paid well as a highway engineer. When I come here before ukutane na 300 kwa highway engineering. The other thing is computer applications. You guys are younger than us. I think you're coming out of school 10, 11 years after we have come out. There's so much development in terms of the IT and ICT. Si tukiwa Jkuat tulikuwa na computer lab moja. Let's imagine ilikuwa na comps G25, ilikuwa pale EMB. Now class yetu ilikuwa na watu 50. So hata kuenda mnaenda na shifts. I think it's a requirement now after we left. Everybody has a laptop, such things. Internet is free. Sisi ulikuwa nenda cyber. So unfortunately, and I know it's campus life, most of us use it for social things, not engineering life. But if you can actually take advantage of what IT can do for you in engineering, there's so much content in YouTube about construction technologies. Look how they are doing AC now. People are actually paving blocks, cabros inapangwa na mkono. There's a machine that lays that thing for the whole width of the road. So many custom-made high-level machines, they're there. And misi ati nilienda mahali nikaziona. They're all on YouTube. But you have to have an interest to actually know, let me use my ICT, this knowledge and ability to actually access knowledge in engineering. Badala ya kudownload to series peke yake na kufanya nini, you also do something that also guides you. I can say, like, personally, I've actually done work with some young guys who cleared school later on to develop an app for construction supervision. And we're adopting it for works here at Tatu City. We're trying to see if we can discuss with some of the authorities and government entities to adopt them. For guys who are resident engineers, like Cedric and the others, and also guys who are working with Konza, tafadhali, when we come to you guys, saidia na kazi. The other thing, modern construction materials. Again, solutions that are there in the internet, like what I was giving. DECRA is a solution that came, is a modern construction material, very common and being originated in Australia or somewhere, or New Zealand, Kochini. The light gauge aluminum profiling, those are also solutions about modern construction materials. And there are quite many, very many more. I think now, and Rashid maybe can mention, we are actually using polymer modified binders in some of the roads. I think those guys who have used thicker road the other day, wamefanya surface dressing, it sticks within a certain time. But when you go to a rural area, when they do surface dressing, those chip-ins will play for that road until a month or so, kanyangi hadi zishike. So they are quite very modern construction materials that are there. If you don't know them as a contractor as well, it hinders you from quoting them when the engineers demand of them, handling them. How do you handle a polymer modified binder? Is it the same way, or polymer modified material the same way? You're getting scenarios where the designers, not even the designer, engineer may could design a nyumba, but or a structure or something, but the employer wants it done miraculously within a very short time. There are adhesive and additives that actually comes with handling of concrete for quick setting and key curing. All these are modern construction materials that are coming. You need to be aware of. It's all engineering. Kuna mtu alisoma CRE hapo. Then management enforcement system is same as application. Health and safety. And sorry, I missed a letter there. It's about safety of the workers and everybody on site. As a contractor, at the end of the day, maisha ni, everybody is here to be alive. So health and safety is quite important, especially when you're doing project in the COVID time. So I know I said I'll show you how to make money, but it's not also that easy. and it needs for you to be involved. As a closing remark, I'll just say this. Engineering si mchezo, that's why they select the cream of the cream to get there. And in practice is not a joke. I've done a lot of my practice in both design and supervision. And my appreciation of construction engineering actually came because of the time I've taken in supervision. Don't come and think that things will going to be academic. My first boss told me that I did a beam and think there was a mistake in the design. And then when he looked at it, he told me it's wrong. He's the current ACEK president. He told me this. This is not class. In class, if you design the beam and it fails, you only lose marks. In real life, if you design a beam and it fails, do you know what happened? I said, no. He said, people die. Or the building collapses and people die. Do you want to die? I said, no. So when you're coming outside in the next 2 years, the mentality that you're going to be like somebody who did a different course need to disappear. And what I can say, yes, there is money. Like any other field, you have to go for it. You have to look for it. I hope it was idea. And another field that you need to tell is in construction, claims and claims management. There's a lot of money in that. There are very many contractors wamepewa kazi because ya kujuana. And they don't know anything. They need you as an engineer who understands the contract, who understands the design, to be their engineer in that company. And most of them, because wajui engineer analipangwa aje ama nafanyanga, wanalipa pesa mzuri sana. But it can't start without you understanding what to do and what you're supposed to do. As I finish, as much as I echo for you to be construction engineers, my advice is the best of your ability, start working for a design firm for your first 2 years. Otherwise, when you meet Cedric or you meet Rashid, he tells you something you'll think is frustrating you because you have never been a design office and understand what is the importance of Rashid achieving his material. What is the importance of Cedric achieving his radius of curve in the highway? So start if you can. I know it's impossible for everyone, but if you can, start with a design office. Start understanding engineering from the conceptualizers. What is their target and why do they do this? That even when they come to site and they challenge you, they tell you to cure a sub-base layer for 7 days, na wataka kufanya GCS before mvua. Unamwambia siku 4 zimetosha bwana. Hata mimi nilisoma kama wewe. All the best guys as you come in. Kujeni tungangane. Cheers man. Thanks a lot Laura for organization. I've had a good time. Bye.
Hey, thank you so much, Lawrence. I personally have learned a lot because I had actually wanted to be a contractor and learn the ropes, you know, until I heard what it entails. You can think you're the engineer, or rather you're an engineer who owns a construction firm and in the office doing your own work, until 2 of the drivers call you and tell you, but a tipper. What are you going to do? And you have to solve that. What are you going to do? You get, so these are the nuanced problems that you handle as a contractor. It's just about your discipline, you know, your mastery, and just don't lose your cool because these things will be there until you come. So thank you everyone who has presented. Now I know the time is not on our side, but kindly we need to jump on the Q&A now. Photos, you had mentioned how anyone wants to speak should raise their hand, or anyone want. In fact, I'm very particular about ladies. I need ladies to ask a question.
Okay, engineer. Good evening, everyone.
Good evening, Photos.
I hope you guys can hear me.
We can hear you.
Yeah, now it has been a very nice presentation. I've captured a few questions from some people who have also requested to ask questions. Mm-hmm. There are also other questions that have been asked in the chat. I've been following, so I'll just post them so that the respective speakers can also answer them.
Okay.
One basic one, maybe this one you can answer to us very quickly. Whether Sesha was asking whether we will be able to have access to the slides.
Yes, you will have access to the slides once I personally collate all of them. We'll also upload this recording on YouTube at a later date, so kindly give us time. Maximum 2 weeks, you should have all the presentation material that you basically see over here.
So we have 3 people who want to ask questions. Catherine Juguna will ask the first question, and then followed by Kezia, and then Gideon Korir, and then we have other questions in the chat that I will just post.
Yeah, okay.
Kate is the first one.
Yeah, I think you can just unmute and then you proceed.
Hi, good evening, everybody.
Good evening.
My name is Catherine Juguna, and I would like to ask Irene a question. When it comes to EIA and GIS, what are the best institutions to learn those softwares or that field or that science, quote unquote? What are the best institutions where we can learn about these things?
So Irene, I don't know whether you're here or she has logged out. It seems she had logged out, but among future leaders, whichever future leader is here, you know, as I told you, me in a margin environment, I have never been that person. I've done materials, basically everything that does about that. So water environment, I am a bit green on that. So if there is anyone from future leaders who can answer whereby if you want to learn AI and GIS, which are the best institutions? No one can answer that. Or we can put it pending first before Irene actually comes back. She just told me she has a problem with her machine. She will come back, so we can put that pending. Maybe what was the next question? Sorry, Kate, we'll get back to you.
Okay. The next question is Gideon Koril, if you can hear me, because Kezia is saying she's in a place that she cannot actually ask, but she can post the question. So Gideon Koril, who had a question in the structural side?
Okay.
Okay, good evening, everyone. Can you hear me?
Yes, we can.
Can you can hear me, eh?
Yes.
Yes.
Okay, this has been a nice presentation, especially from Engineer Njue. You made me have an interest in the construction aspect. So my passion is on structural. So my first question is to Engineer Francis Mwangi, because I saw him, he was the one tackling structural aspect. So my question is, while you're doing a slab, let's say it's a two-way spanning slab, around 6.1 meters by 4.8 meters, then you find that your design requires T12 size, then it's costly, but the slab has not failed in deflection. You have T10 instead of T12. So which one is it more recommendable? Is it using a 150 millimeter stick slab or 175 millimeter stick slab, or you go for T10 for the entire span since it does not fade in deflection?
I mean,
Thank you, Gideon.
to me that sounds like a design issue, but
question. Yes, I'm happy to hear that our engineers are already doing design. So now we should quickly move to the Lawrence side of making the money. I thought you had not gotten to this point. It's actually commendable.
Okay.
My quick take on it would be there are various slab types that you can employ. There are waffles, there are hollow pot slabs, there are solid slabs. Now we have the new beam and block systems. So the question is, what is restricting you from using any of those other systems? But to answer your question directly, you're saying you have D10s and you have D10s, but the slab requires you to use D12s. All you need to know is that we don't design for diameters of rebars, we design for area of steel. So if the area of steel that is required would need a closer spacing of the D10s, then that's what I would propose that you do instead of going to the 175 thick slab. I hope that answers the question.
Can I still engage engineer?
Sorry?
Yes.
I do still some clarifications.
Yes.
You are doing, my question was, you are doing a solid slab.
Yes.
A solid slab. But your design requires T12.
Yes.
For 150 millimeters thick slab.
Yes.
Now that it does not fail in deflection if you use 175 millimeters thick solid slab. So which one is it more recommendable? Since the client is complaining on the cost on 175 millimeters thick slab, and you have been fixed actually by the, you are using a spacing of 150 millimeters center to center. So if you do 125, kind of it will be over reinforcement.
As I told you, you don't design for steel bars. You don't design for diameters, not like D12s, D16s or whatever. What you design for is the area of steel that you require on that section of the slab. So if you need like 300 millimeters squared per meter, then all you need to do is just divide that by the area of steel. That one D10 would give you maybe 78.5 in this case, and then you just come up with your with the spacing of the rebars. That is the direct way of approaching it. The other option I had told you is there are 10 or so other slab types. So when the employer tells you that this is the restriction we have and cost is a driving factor in this case, then you tell him there are other alternatives that we could use. Some of them might prove cheaper. Some of them might even have the aspect of ease of construction, such kind of things. And that's how you win your battle, not on cost. As an engineer, you need to show the other technical aspects that you're bringing onto the project. Otherwise, anybody else would be able to just do the cost bit.
Okay, thank you, engineer. Well answered.
Engineer, now there are some other questions that you asked on the chat. A few of them have been answered. The first one, the next one was a concern. Somebody, an engineer, James Musa, was saying, if you could create more time for the presentation.
If we create more time for the presentation?
Yes, like the time was a bit short for what we were supposed to cover. So you are actually hurrying the speakers. They were making very important points.
Noted. As we even realized, we allocated 2 hours, but honestly, everyone had something a bit more to say. So what we do, as we learn, we now know that 2 hours is not adequate, especially that this is a very interactive session. So probably for the next one, we'll do 2.5, 3 hours. And also as ACEK future leaders, it's not that we just come, do a presentation, and then you'll never hear from us. No. As from the chat, you can connect to us via all our social medias on LinkedIn, on Twitter, on Facebook. Then you also have our email address. So we won't leave you in the cold as is now. Anytime you want to reach to us, there's always someone who is ready to respond within a few days. Yeah.
Yeah, I don't know whether Engineer Rashid is still present, but there's a question to him that if you encounter a large area of expansive soil, what do you do?
Area of?
A large area of expansive soil.
I think that's Mohammed?
Rashid, yes.
Rashid, yes, Rashid.
Okay, thank you for the question. When you have a large area of expansive soil, the best thing and the best solution is to completely remove it. However, there are some, when it goes maybe beyond 1 meter or 2 meters, it's not possible to remove. So what do you do in that case? There's whenever you start excavating, it starts, there's a junction or a borderline where there's some kind of what we call calcrete gravel that shows after 1 meter, immediately after 1 meter. Or any kind of border. If you encounter that border that shows you moisture fluctuation zone, what we are interested in black cotton soil, the only problem is moisture fluctuation zone. So as long as you have removed up to where the moisture fluctuation zone is, you should be okay. Otherwise, the best thing for black cotton soil is to be removed. Expansive soil, remove. Especially if the thickness is not very high, or if there's it's on top of a hard surface. That means it's going to hold water, and it's going to swell and crack, and it's going to be a problem for the pavement in the future. So I think that's, I hope I answered your question.
Yeah. So the rest of the question
maybe,
will email you. Yes?
Maybe just to add on that, I've also had an experience, like for example, it depends actually on the type of pavement that you're doing, because some pavements cannot allow you to do what Engineer Rashid is saying, because of the kind of utility the pavement is intended for. For example, when we were doing the runway at Kisumu Airport, the runway has sections, the touch pad, the runway itself, the turn pad, and the parking. So the pavement structure on the touch pad is where the aircraft hits when it is, before it starts running along the runway. That area around the lake, because we're extending the runway from 1.2 kilometers to 4.5. 4.5, yes, 4.5. So it was having a lot of black cotton soil, going up to almost 4.5 to 5 meters deep. So that kind of a pavement, you really have no option but just to remove, because you cannot be able to give enough strength on that pavement for it to carry the weight it's intended to carry, using a remedial measure that still has a black cotton soil within it. But now there's some pavement, like what Rashid is saying. If you have, say, for example, a T4, okay, let me not use those words. Say a pavement of a normal highway or a normal road, like for example, if I say T4, I'm going to confuse this guy so much. Say a normal road, like say Uhuru Highway, for example, where you know your loads that you are expecting for the vehicles going to be riding on it, is what now you do what Rashid is saying, because once you achieve, and normally we usually do 1.2, Rashid, am I wrong? I think I'm 1.2, no?
Yeah, it's 1 to 1.2 meter.
Yeah, 1.2. Now you can remove 1.2, then you start building up from there with imported material. Should be able to give you sufficient strength. It depends on where you're dealing. Actually, it depends. Yeah, I hope I've answered.
Thank you very much. That question was mine, and it is well answered.
Okay, Engineer, the rest of the question will email you. We have your details, and we are very grateful for this session. We have so many questions, but I'll capture all of them and then we email you to tell.
Yeah, okay, no problem. I'm even seeing from the group chat, there are questions there. We are so we will handle them one by one. Otherwise, what I'm seeing is it's 17:43, and you know, maybe some people will want to rush somewhere. So we just want to, if you allow us, to close the Q&A session, but we know we'll get back to all these questions. So I would just want to introduce our chair, Engineer Latoya, to come and say something small. And Engineer, are there any senior engineers from ACEK here?
No, not this time.
Not this time. It's okay.
Yeah.
They will join us next time.
Yeah.
Yes.
Hi all.
How are you?
I'm trying to get where the light does not reflect as much. My name is Engineer Latoya Ona. I am a structural engineer and a contract specialist. I studied BSc Civil Engineering in the University of Nairobi and MSc Construction Law and Dispute Resolution in the University of Central Lancashire in the UK. So currently I'm the chair of ACEK Future Leaders. ACEK Future Leaders was formed in 2014 by graduates like you, me then, And it was formed as a way of networking and getting to know each other and building our career base and going forward in the engineering profession. So it is under ACEK, which is also under FIDIC. FIDIC stands for
Federation International.
I don't should ask Lawrence to break it down for me. Yes, FIDIC is a body that is an international body where that controls our construction contracts. Yes, so under FIDIC, they register consulting engineers in all around the world, the US, Europe, Africa, and in Africa it's called FIDIC Africa, and which ACEK is a member. So we have the advantage as ACEK future leaders to collaborate with other FIDIC Africa members like FIDIC, like CISA, South Africa, Botswana, Nigeria, and Uganda. Today we even had a Zoom meeting or presentation by future leaders of Botswana. So those are some of the advantages of joining FIDIC and future leaders, FIDIC future leaders like us. And also you get to join us. We do a lot of mentorship, we do a lot of networking, we chat a lot, we have a lot of deep and thought-provoking conversations in our WhatsApp group, and we give each other business and we give each other referrals. So that is basically what our organization is aimed at. So I hope that once you graduate, you will be some of our members, and you can help us carry on the ACEK future leaders for other future graduates, yes, other future graduates, and it can be a force to reckon with in Kenya and in Africa. Besides that, of course, you'll have to join IEK and EBK. The presentations, everyone assumed that you need to be a member of a professional body, which is Institute of Engineers of Kenya and Engineers Board of Kenya as a graduate engineer. Then you work for about 3 years and you can now apply for a professional engineering certificate. So with that, I'd like to thank so much our speakers. They have taken their time and to share their profession and to share their passions, and you could see in their presentations that they have really put in a lot of work and they really want you to know how it is, and so that you don't fumble like us, you don't get lost, and while the other people who can actually help you through it. So I hope you've learned a lot. Thank you so much for coming. I'd like to, of course, thank Engineer Francis, Engineer Cedric, Engineer Rashid, Irene, I think has left, and Engineer Lawrence. Thank you so much for taking your time to volunteer and take these young engineers through what life in engineering would look like in 2 years. And I'm sure they're grateful and they'll keep you in mind. Don't forget also that they will be coming out here and they will need physical help like internship and probably employment. So yes, we have that in mind too. Thank you so much, Alwara, for organizing this. It's been wonderful again. First was University of Nairobi, now it's Jomo Kenyatta, and it's still a great success. So thank you so much for taking your time. I know it's so lengthy and it's back-breaking work, but you kept at it, and we are grateful. We are very grateful for it. So yeah, from me, yes, I think I've been sharing our social media handles. We'll communicate there, we can chat there, whatever you want to, whatever that was not clear, whatever you would like to be helped with, you can find us there. You can find us on email. Many of us personally answer the emails and answer the social media platforms. So you can find us there. Spread the word to fellow engineers that you know, fellow graduate engineers, that once you leave, come and join ACEK Future Leaders so that you can grow yourself, you can grow your career, and you can grow your knowledge. So that's it for now. It's 5:50, and I think I can call it closed. Can call the meeting closed, and you are free to leave and maybe engage a speaker privately or how, yeah.
However,
Yeah.
can we meet in public restaurant?
Yeah, officially closed. So thank you. Request for contacts to be shared. Jesse, just email us, and I will deal with that reply. Yeah, I don't think I can share them publicly here, so just email us and we'll get back to you. Yeah, so thank you and have a good evening. Bye.
Thank you, everyone. Thank you, everyone, for showing up. We will not let you go. We will not let you leave. We will let you free. We will still engage you later. Asanteni. Thank you.
Bye.